Hello everybody, welcome back to Handmade Runes, where we code graphics application completely from scratch in the Odin programming language. This is session number 4, and we have a lot to cover because I really want to get us out of the quagmire of the Win32 platform layer and up to more interesting, fun things that have to do with actual graphics. So I want to finish everything that we could in this session about using the platform layer, and yeah, and then it'll be fun from there. So we have a lot to cover. We'll first quickly do some stuff relating to, well, first we'll do some cleanups and structuring, because our application layer is getting a bit gnarly, and it's probably better to start doing it earlier rather than later, before we continue, because we're gonna be adding a bunch of code to the application layer, and it probably should be structured before we go do that. So we'll do a bit of cleanup, then we'll do some stuff relating to refreshing the screen. I recently posted a video in my other YouTube playlist. You should check it out, because we're basically going to be doing what I talked about there, relating to refresh rates of the update and moving stuff around versus rendering. We'll show some actual examples of all the things I talked in that video, so please check it out. And then we'll do all the input stuff. We'll do keyboard and mouse and raw mouse input, and the raw mouse input is gonna be the last thing that we do, and I really want to get this over with. It's very gnarly. I'll try to blast through it so it doesn't take too much time. I don't want to bore you to death. It's pretty low level, gnarly stuff. But anyway, I'm getting ahead of myself. Let's start doing some cleanup. So first of all, I noticed that I did some very obvious mistakes. Obviously meant to do like the width 640 by 480, and I think I had a typo in the printout. Yeah, so that should read frame count. Okay, so let's see. So we have some stuff here relating to like frame buffer and pixels and rendering stuff, and we have some stuff here relating to the rendering, and we have a bunch of stuff relating to timing. We focused a lot on timing in the past session, and so basically I'm gonna start moving things out of here into their own files. So first file, we'll call it I don't know, render.odin. I will start moving stuff out of the application file that have to do with rendering. So color, pixel, horizontal line, frame buffer, etc. Resize we're gonna leave here because it well, I'll get to that. So we'll put this here. Of course it has to be package application. Done. Okay. So we're gonna be doing a bunch of stuff in resize, and not just resizing the frame buffer, but everything that has to do everything that is inside of here currently all has to do with the frame buffer. So we can say resize frame buffer procedure, right? And we'll just forward the arguments there. We'll move it over here, and we'll do this. Whoops. Render this and move all of this here. Alright, and then in application we'll just forward the arguments. Okay, old render, we're not really using that anymore. Our new thing is working fine, even better, and looks nicer and faster, etc. We're gonna be wanting to time this, just this portion here. So we'll still have this render. So the reason I'm leaving resize and render in here in the application file, because that's kind of like our external API, basically the stuff that we're exposing to the platform layer. So this is gonna stay here, but it's gonna be relatively shallow, so it's gonna just delegate calls to some other thing. So I'm gonna move the actual rendering code out of the application file and into here, and we'll call this some kind of proc, like draw weird colors, because that's what we're doing at the moment. And obviously much later we'll do much more fancy things. This is just temporary while I explain other things and how to do them. Okay, so we have this, we're using the frame buffer, blah blah blah. Let's go here, and this is the only thing that we're currently doing in render, and other things will follow. So pre-render and post-render are kind of like the things that we do before rendering and after rendering, right? So we'll just move that here. Won't have post and pre anymore because it's just gonna be inside of render for now, and then yeah, you'll see. Okay, so we're just like wrapping our render with before and after. What else? Yeah, so this is our render, and we'll have other stuff here in update. Okay, cool. So in all of these other stuff that we're currently doing, so first of all, these two lines here are just initializing our frame buffer, right? So we can go here and we'll move it here. Init frame buffer proc. Okay. And actually, you should probably just do this allocation right here, this part of the initialization. Alright, next. Yeah, so all this stuff has to do with timing, right? Let's do a new file. We'll call it time.odin package application. Okay, so let's start moving all the stuff in our application layer that has to do with timing into there. So these are all our stuff, right? And we can do like init timers, whatever, proc. Application. All of this stuff and this, I'll just do that. right? Timers. Okay. And the only thing that keep going to Windows. I'll just close this platform layer. Okay, application. The only thing that we're gonna be doing here is just delegate to this procedure. Just pass on the argument as they are. And of course we're gonna have to call init frame buffer as well. Okay, so that's our init application. Let's move our ticks and stuff that relate to time, put it here. Okay, this is already getting much cleaner. We're doing a bunch of printing. What I ended up liking to do is to put here this and then just say print is font print line, right? Just capture that with just a simple print. We don't even need this for mem anymore because we're allocating things differently. We haven't needed it for a long time actually. So this is our rendering stuff. Yeah. And that's the update. Let's move the update above the render because it happens before it. Getting somewhere here. Yeah, so the thing is that we're gonna be wanting to time different things in different places. So what we're gonna end up wanting to have is different timers. So all of these stuff, like before, after the delta, the accumulated stuff, how many milliseconds, how many microseconds, all of that stuff we're gonna want to have separate ones for different things that we're going to want to time. So we're just going to make a struct. We're going to call it timer. It's going to be a struct. And then we'll be able to just instantiate all that stuff multiple times. So now, because it's a struct, we actually need to change those to that. Right? Okay, so we're gonna want to render timer and an update timer, and they're both gonna be timer of that type. Okay. Get ticks is a global thing. Ticks per second is a global thing. Milliseconds per tick and microseconds per ticks are global. Ticks of last report. By the way, we may want to use seconds per tick. I think we're gonna use that later, so we might as well. And we're basically gonna do the same as we're doing here. Just do 1 over instead of 1,000 over. Ticks of last report. Yeah, that's still a global thing. Okay, so we have this timer thing, and then we're going to be wanting to maybe do all these operations of like accumulating and converting to milliseconds, and then like accumulating and doing like the summary for a particular timer. So first of all, what we're gonna be wanting to do for like all this before, after, delta, blah 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 blah, this is all gonna be in the render, so it's gonna be using the render timer, right? we can do like all this logic of computing the deltas and all that stuff. We'll just move that into timer and we'll have it in a procedure, and we call it accumulate timer. I don't know, something like that. Proc, right? And it's gonna be using some timer. It's gonna be passed by pointer, right? So all of these guys are gonna be using the fields of the passed in timer, right? So, and then in our application, in here, we can do this. We can just pass in the pointer to our render timer. This can now become just print. Okay, let's just see that we haven't broken anything, and of course we have. So seconds per tick, blah blah blah. Where is it? In application. Is it? No. Application timer. That's in timer. So we have all these guys that, whoa, wait a minute. Seconds per tick, blah blah blah. Did we? Oh, okay. All of these guys. I got overzealous here. Okay. So these guys are actually globals. They're not going to be part of our timer struct. Only these guys are going to be part of our timer struct. All of these guys are global. Alrighty. So ticks per second. We have it twice here. Okay. Never mind that. And what? Yeah, totally copied it twice by accident or something. Anyway, let's see now. Seconds per tick and ticks of last report. Did I delete the wrong thing? Ticks per second. Anyway. Totally messed up something. Doesn't matter. Let's just do this. Ticks of last report is going to be a U32. Seconds per tick. I haven't actually. Seconds per tick. Ticks per second and ticks of last report are gonna both be U32 because they're counting ticks, which is an integer. Everything that's counting time is gonna be a fraction, so it's float. Okay, we're compiling and we are good. Haven't broken anything just yet. Okay, so now we're a bit more structured, we're a bit more cleaned up, we can start doing the rest of the stuff. So let's go back to the platform layer for a second. And so we're doing this update right here, just before we're putting the bits, every time we paint. And there's a different way of doing that. We can have it, because the paint is gonna be invoked in all kinds of circumstances that Windows decides to call it. And what we can do is to have it just blit, like set the bits on the device of whatever is currently in our frame buffer, right? We're not actually gonna update in here. We can instead go down here. We don't need all that. Now all this stuff that we were doing, we're gonna actually want to be doing that in the application layer, and we're gonna be doing it a bit differently. So I'm just gonna get rid of all that for now. Okay, prior current ticks per frame, because now we have multiple timers, so we can start reusing the logic there. And we're gonna put the update in here. Yeah. So on each iteration of the loop, we're first going to be doing the update, and then we're going to do like all the dispatching. No, actually, let's do it. Let's do it after we've processed all the messages, so we can have inputs and stuff. And then we're going to update, right? And then we're going to invalidate the region, which will end up drawing our stuff, right? And we can get rid of some, right? Or don't we? Yeah. Maybe it's 6 per second, that's fine. Oh, so we had all these guys here. Yeah, we'll just get rid of that. We're gonna be re-implementing this thing in the application layer in just a bit. Okay, we're gonna still need the application, etc. Okay, so we've disabled our frame cap, frame rate cap. We'll deal with this in a bit in a different way. Now what you'll notice here is now when I'm resizing, what's gonna happen is the moment I release, then it does a repaint, because it ends up finishing here with all the resize messages, and then it's doing an update, and then it clears up. But as long as I'm still resizing, what ends up happening, if you saw my video on frame buffers, right, I'm basically end up desynchronizing how the frame buffer's representation of what the display of itself is going to be like in terms of like width and height, right? Such that it thinks it's still in the old smaller size. So whenever I'm like doing like this and stretching it, right, and all those numbers get wrong and repurposed to some other place. So that's the kind of thing that you're gonna see if you're resizing and not syncing your frame buffer's interpretation of how it's going to be painted. So what we need to do is whenever we resize, and the only thing that we're actually doing here in resize is getting the size and calling our resize here, which is resizing our frame buffer, but it's not actually redrawing and using the new information that we have reset to generate a new frame anymore. Before, what it was doing, because every paint we're doing an update right here, then right after we resize we get a paint message, and then we update, right? So we did do the resize. I take back what I said. We did update our frame buffer's representation of itself, but we haven't actually used that information between the time we resize to the time we paint the next frame. So what we end up wanting to do is inside of the resize, right after we resize here, we can either update or we can render. Update will also do like other stuff like capturing input, But like for resize, for now, we can just get away with just doing the rendering itself, right? So now, immediately after resize, we are repainting using the new size and dimension information. So we're no longer getting this weird effect. All right, let's just start talking about what are we doing for update, and how are we gonna sync our movement to be in constant time, with or without actually capping the frame rate, as I discussed in my video about that. So we're not going to be capturing input just yet, but we do want to see some movement that happens in the update. So what we're going to do for starters is just move everything, like offset it to the right or to the left and up. Let's just start by just offsetting it everything to the right or something like that. So we're gonna have some offset dot x and gonna increase it by 1. And what's an offset? Let's define it. We can do it in render. Actually, yeah, let's keep it in here. Okay. So we have an offset, and it's gonna be 2 floats, F32s, you'll say. We can do F64, I guess. It's fine. Okay, so we're gonna start with 0, and every time we update, we're gonna just increment it by 1, and we're gonna use that offset. The reason I can actually do .x, if you're unfamiliar with that, is the fact that in Odin, anytime you do like an array of some number, as long as it like up to 4, like the first 4 ones are gonna have like XYZ and W and RGBA. It's just a convenience to access it to do like mathy stuff. That's just built in Odin. So like we could have just done this. It's absolutely exactly the same. Anyway, so we have some offset, and we want to be able to apply it when we render a new frame. So not resize, actually drawing the weird thing. So inside of here we can do this, right? The y plus the offset. So in here we'll just do F64 of this guy, and in here F64 of this guy. And currently we're not updating the y, but we soon will. So this is gonna be y, and this is gonna be x offset. So we're just gonna be saying whatever color we have, instead of just using the y, we're gonna be using the y plus some offset, and whatever we're using for the x for, like where our pixel is on the screen, horizontally, we're just gonna do whatever the x plus some offset, that's whatever in here. And these are all gonna be initially set to 0, and in our application layer, every time we update, for now we're just gonna be incrementing x by 1, so moving everything to the right. Alright, see how that looks. This is moving, okay, it's moving very fast, and it's actually, I think, moving to the left. And as you can see, the speed is changing depending on the resolution, which we don't want. We want a constant speed, right? The more pixels move, the slower they move. We don't want that. That's not good. Okay, so first of all, why is it moving to the left, because when we go in here, when we add an offset here, what you're actually saying is, instead of using our current position's X, use whatever the current position to our right, right? Which ends up like making it appear as though we have moved everything to the left, because for every pixel we're instead of drawing itself, we're using the one next to it on the right, but we're doing it where it is. So it's like we have moved the pixel to our right to where we are. So that's why we've actually moved everything to the left. But anyway, we saw our problem here, so we already know how to fix that. If you've seen my video, I'll leave a link in the description also, so you can watch that. Okay, so we're moving this, we want to move it in constant speed, and we have a few ways of doing that. So one way of doing it is, first of all, we do have our own timer now, the update timer, that we're currently not using. We're using just the render timer, right? So we could do exactly the same that we're doing here, but just using our update timer, right? And as you recall from the video, what you actually want to do is, after we do the update, this is our update right here, right? But just before we do the render, then we take a time step which is gonna be before, and then we're gonna count for however long it takes to render, right? And then we're gonna take the after, and then we're gonna do the delta, right? So the delta is gonna be after minus before, and that's the delta ticks that it took since the last time we updated it. Now this thing, yeah, so this before here, we have like what's gonna happen the first time around, because we haven't even got to here even once. So we do want to have this happen at initialization time. So we're gonna do that, and it's gonna be in our update timer, right? We do have some value that's gonna represent the thing that happened before our prior render. We didn't even have any prior render yet, but at least it's not like yeah, it's not going to be 0, because otherwise what's going to happen, because these numbers are going to be huge, right? So with the delta is going to be something that we can actually use, but if we do like this huge number minus 0, it's going to be insane. So we don't want that. We want it to be something relatively close, even if it's not accurate. It's just going to be in the single frame. We're not going to be noticing it anyway, unless it's huge. So yeah, this is fine. Okay, so we have our delta. So now what we could do, one of the things that we could do, is do a for loop, which is technically a while, but in Odin we don't have a while, so we can do for as long as delta is less than, you can say update refresh update interval, right? Do and just do these two again, right? And we don't don't actually have to update after itself. What we really want is just to update the delta, make it bigger, so we can just do that in one line. Okay, so our update interval, we're just gonna have it here somewhere, and that's going to be first of all. Yeah. So it has to be in terms of ticks. We have a problem. It can actually be like a compile time known constant, because we do want it to account for the ticks per second, like the tick rate, right? Yeah. So we can do like it's gonna be a U64, right? I do want to keep it here, I think, and not in the timer, because it's kind of like more application level thing. And yeah, so what we want this thing to be, here is, say we do like a 60 FPS. That's the update interval for now. Okay, so what we want is to represent is how many ticks does 1/60th of a second represent. So it's going to be however many ticks there are in a second divided by 60, right? So what we can do it in timers, or we can do it here. I'll just do it here. So this thing is going to be equal to ticks per second, which we will have had by the time after we've initialized our timers. So this guy over 60, right? And maybe we don't want this magic number, so we can call it target FPS, right? So we'll say target FPS is 60. Okay, so this should make us golden for waiting, like burning through cycles, enlarging our delta until it reaches our update interval, which is going to be like 1/60th of a second represented in ticks. And then we're going to do the update, and then we're going to be doing the resetting the before and doing the render. So if we do that right, then we should see that we'll now be always doing a frame count of 60 or about. And because of that, we'll be also updating in a consistent interval, and so we should be moving in a constant speed regardless of, like, because of the frame rate is going to be constant. Let's see if we get that. Ticks per second. I did it with a capital. Okay. Let's see. So now it's moving pretty slowly, but look, it doesn't matter how large the screen, and we are in fact rendering at a consistent 60-ish frames per second, regardless of how big this thing. I've stretched it beyond the point that you can see on the screen here, so it's pretty large, and it's still moving at the same rate. So say we wanted to move faster, so we can say, well, speed, let's say, I don't know, 4, right? So we're gonna be moving like that. Okay. So now we're moving faster. Okay, but we're still moving at a constant speed no matter what, because we're updating at a consistent interval. Okay. Yeah, at this point you can see that while I'm doing the resize, we are rendering, but we're not updating. That is because I did this. Now if we did want, we could just do that, and then we will do both the update and the render while we're resizing, which looks like this, right? Okay. Oh, that's fine actually. Okay, so this is the approach of like capping the frame rate. So let's now, instead of doing that, we'll just um, let her let us render just as fast as we want, and we're gonna modulate our speed by the delta, so that we just move it at a constant speed like I described in the video. Okay, and we will need to convert that to a floating point. So this delta is going to be a 64 and 64 bit number that's going to include going to hold the number of ticks that passed between between frames. But like we don't want it to be dependent on ticks. We want it to be dependent on time, because we want it to be like platform independent in terms of the speed, and ticks change in per platform. So what we want to do is say multiply that by seconds per tick. This way we're gonna get some fraction that's gonna always be in every platform, because like the differences in ticks is gonna counteract between these two, and then we're just gonna in any case we're gonna get some fraction in terms of time. Now we're currently doing like thousands of frames per second, right? So like how long does a single frame actually take? We can't really tell. We need to change the way we're reporting it, from reporting frames per second, which is actually not a very useful measurement because it changes non-linearly, because it's like below the division line, so it's like a reciprocal. So instead we're just gonna use like what's the average microseconds per frame, right? Just show me that thing as it is. Now, currently it's going to be moving at incredible speed, as you're going to be seeing. No, actually very slowly because we're dividing it. With the fraction is now very small. So we're doing like 320 something. It takes about 300 something microseconds to render a single frame. So this is gonna end up being 1 over 330 something milliseconds. So it's like 320 millionth of a second, right? So it's going to be very small. So it's going to be moving us very slowly. But it's also like we're not capping the frame rate, so we're doing like thousands and thousands of frames. So it's kind of counterbalance it, and the speed that we're getting is kind of slow. Let's just increase it by 10. Okay, we can work with that. I don't know, we can do 100. We can do 240, which I think will be, yeah, that's basically our speed that we got before, because like before we were doing like 60 frames a second, we're moving 4 pixels each frame. So we just plug the speed. Now this is per second, right? So our speed is 240 per second, and then it's going to be modulated by whatever fraction of a second it's going to take to render a single frame, and then it's going to do that many times a second. So we end up having the same speed, and look, we're now like rendering all kinds of incredible amount of frames per second. But as you can see, and it fluctuates in terms of how many frames we're rendering and how long it takes, but our movement is still remaining constant, right? Because we're modulating our movement by the movement speed, we're modulating it by however long it took to render the prior frame. Now you can see that when I'm resizing currently, it does render properly, but it's not moving. Well, that's because I did this thing where I'm only doing the render and without doing the update. So it's rendering in the correct resolution, but it's just using whatever the last values that we have for the offset. So if we want to change that and we want to have it continue to be updated and rendering while we're resizing, then we can just do update instead of render. And then we can see that while I'm resizing, we're still moving. So everything's working. Okay, so now instead of just moving all the time by that speed regardless, we can start having it only happen conditionally based on user input. So let's just start talking about that. So let's just say that we're only doing that if move right. If we want to move right, so this is actually, so it's moving everything to the left, and that's kind of what we see when we ourselves are moving to the right. In relation to us, everything is moving to the left, right? So we can do that, and then we can also do this and decrease it if we're moving to the left, right? So we're decreasing instead of increasing. Now this is gonna get also, it's the same amount every time, so just gonna say amount, yeah, it's gonna be this, right? Okay, so this will move us right and left, and we'll need to obviously make this global thing and populate it. But let's just finish this. So move up. So let's think about it. Why? So moving up, I want to push our pixels down, so we're going to do that. Okay, so we need, let's create a new file that's going to hold our input. So we're going to say package application. I'm going to save it as input.odin. Okay, and we're going to have move right, move left, move up, and move down, and they're all going to be bools, right? Now we're going to want to set those based on user input, in this case based on we'll start with a simple keyboard like WASD keys. So we're gonna be wanting to expose to our platform layer a key changed procedure, right? And we're gonna ask like which key are we talking about, and it's gonna be a character. And you're gonna ask like, well, is the change that is pressed or not, right? And then we're going to say, well, we can switch on the key, and we can say if the key is W, right, then we're going to update the move up, because that's our move up key pressed, right? And we want to do the same, like S is going to be down, and A is going to be left, and we actually need capital letters for these guys because that's how Windows does it. And I think it is, yeah, we can talk about like making a cross-platform thing later. I think like most platforms this will just work. Yeah, we can talk about that later. Anyway, so we're gonna move to the right with D, right? So now we need to expose this procedure to our platform layer. Such that anytime any of these keys is changing, then our state of what the keys are is going to be updated, and such that by the time we get to update, these conditionals will work, and we'll update the offsets accordingly. Okay, so let's go to Window, and we're gonna need some new cases here. Some cases for when the key is pressed down and when a key is pressed up. So let's see how that looks. So it's gonna be WM key down and WM key up, obviously. And we don't have those, we can go look it up, and I'm gonna cheat and I'm just gonna update and put it in our constants. You've seen me do this kind of investigation of getting these numbers before, so I'm not gonna belabor on that. Okay, so yeah, so in our platform layer, in any of these, we're gonna want to call our function there, our input procedure, right? In our application, so that's our key that has changed. If it's going up, then press is gonna be false, and we need to provide a key. Let's talk about how we do that in just a second. If it goes down, then it's gonna be pressed, so it's gonna be true. Okay, so how do we get which? I can type true. So how do we get which key from the parameters of this procedure? So it turns out that the W param itself will, in this case, just hold the key code for our key. So it's gonna, and we need to cast it to U8 because we know that that's what we're expecting. And for cases like simple letters on the keyboard, it's just gonna be like the ASCII code, which is exactly what we want. Right. And of course, I've forgotten some stuff. Oh, yeah. We want to call this procedure. Don't want to redeclare it here. All right. So now we're not moving at all, right? But then I can press the D key and we're moving to the left. And when I press the A key, we're moving diagonally, so we have a bug. Let's see what I did wrong. This looks correct. Let's go to our input. Up, down, left, right, WSAD. And so our rendering is, our offset is where we're doing it wrong. Right, left, up, and left, obviously. So we want it down. Okay. So right, left, up, down, right? So we have our WASD keys working. Cool. Now let's start talking about mouse. This is going to be our next big thing, and it'll probably take the rest of this session to cover because there is a lot to cover for mouse input handling. So let's start doing the simplest things, which is just capturing where our mouse is. There's actually a few ways we can do that, even before we get to raw mouse input, which we will get to. But let's start with kind of the simplest way of doing it. So there is obviously a mouse move event, and it's gonna be something like case Windows message mouse move, and what we want to call is we're gonna be wanting to call like mouse moved, some procedure that we're going to be defining, and we're going to be wanting to pass some x and y values, and we'll see how we get those. But first of all, we don't have a mouse move yet in our constants, I think. Yeah, so let's do that. So this is going to be our mouse move. It's going to be some constant, and you saw many times how I'm getting that. Now it's gonna get a bit tricky in our platform layer, because we need to get the x and y position of the mouse at the point that this is called, and unfortunately it's kind of tricky. So if you look it up on the web, you will find that you use some macros that look like this, right? Get x param and get y param. Now these are C macros, and they do a whole bunch of things and call other macros which do even more horrendous things, and all that's doing is trying to extract some bits out of this L param thing. Alright, so I'm gonna spare you the trouble of trying to emulate what those macros are doing, and because what they're actually doing is just a bunch of nonsense. So get x param is going to get like an L param. Both of them are getting L param, even though they're calling it here something else, because they're going to be extracting different values out of the same thing that we're passing onto them. So one of them is going to be calling low word, and one of them is going to be calling high word, and and go through a bunch of conversions, and those are going to be all kinds of shenanigans of conversions, but what they're actually doing is like, we got FFFF, which is like the first lowest 16 bits of the thing, and the first one is just gonna mask and take those, and the second is gonna take move the whole thing 16 bits to the right, and then mask it, and a bunch of bullshit type conversion going through pointers in the back or whatnot. You can look that up. I've already shown many times how to do that. Basically, that's what these macros end up doing. So we get an x in value. Now, so we do have to actually implement this thing. So we'll go to input, and let's implement this procedure. So it's gonna expect an x and y values, and these are going to be just the integers which are assigned. So it's going to be I32. And now unfortunately it's going to it doesn't give us the deltas, it just gives us whatever it's currently at. So you're going to have some mouse position that's going to be to I32s, and we're going to basically end up having to compute the deltas ourselves in this way of doing things, which we won't end up using, but I want to show it. So so we're going to do mouse position.x is going to be equal to x, and mouse position.y is going to equal to y. But before we update our current thing, what we want to do is compute the deltas. So the deltas is going to be mouse deltas. I'll call it delta. Mouse delta.x is going to be whatever we currently it's going to be wherever we're currently at, the new thing, minus wherever we're going, wherever we were before, right? And the same for y. Okay, so now we have our how much we have actually moved. Okay, so now in our platform layer, what we want to do is, in addition to handling the keyboard, we want to move stuff based on the mouse as well. So let's say that we do have some mouse delta.x, which is in the 0. So then we're going to do offset.x, and so the mouse delta is going to move to the right if it's a positive thing. Right? Yeah. So yeah, we can do basically the same thing. As we do here, and if we don't like it, we'll change it. So let's just see. And we're gonna do the same for y, and we don't need to do like the plus and minus stuff, because these are signed integers, so they're gonna be either positive or negative, and so we can just accumulate it if that is indeed what we want to do. Let's see what we get. Expected operand, syntax error. What did I do? Obviously I need to compare it to 0. Alright, so and in window I did something wrong. I think I'm missing this guy. Oh god. Okay, so in our bindings, in all this stuff that I've added. There's a bunch of stuff that we actually don't have yet defined. So, short. We don't have a short, as it turns out. So let's go to our types and define a short. And of course, a short is going to be an I16. And what else? While we're at it, I think we're going to need a U short, which is going to be an unsigned 16, obviously. Okay. D word pointer. D word pointer. So it's just gonna be, let's see, we have a D word, I think. Types. Yeah, we do. So a D word pointer, I think it's just gonna be a pointer to D word. Right? Let's see what we got. And I probably mistyped something. Mouse pause and mouse della. Okay, and as you can see, we're doing this thing, and it is respecting my mouse movement-ish. But then when I stop moving, it's still moving because I haven't reset our deltas. Now we should technically do it inside of these guys, but we can also just do that. All right, but it doesn't seem to like me. Let's see. So first of all, you can't just use always increment by the same amount. What we want to do is multiply that amount by the amount that we actually move, right? Alright. And we need it as an F64, I think. Because currently it's an I32. Okay. So now we're moving our mouse and it's moving, but as you can see we have a problem because once our cursor is getting out of the screen, we stop getting any inputs. And this is why it's not really a good fit in terms of how we're capturing the mouse inputs. We want to get the mouse inputs even when we're outside of our screen. So how do we do that? Alright, so let's see. First of all, we go to our platform layer. And as you can see, so this thing that we're capturing only ends up being invoked for capturing the cursor while the cursor is over our window. Otherwise, it doesn't issue a message. And that's not exactly what we want, right? So let's just comment that out and do something else instead. So instead of doing it this way, what we could do just before we update is actually ask explicitly what is the current mouse position, and we can do that with a call to get mouse cursor. Get cursor position, sorry. So this is a call, and it let's see how it looks. I'm going to spare you again the process of getting where it's from. Let's just go to our bindings, and it's a very simple thing. And what it does, it takes a long pointer to a point. Okay, so we need to provide it some point, and it, I guess, puts the coordinates of the new mouse position into that point. I think we do actually have a point, yeah, but we don't have an LP to a point, so that's just a pointer to a point, right? And of course, we will have to have some point in our platform layer, so such that we can have something to provide. So let's just define that. So we have a point, and now we are getting the current position into that point. That's relatively trivial, and then we'll do the same thing that we did here of calling our mouse move, but instead of using this, because we now won't have the L param. This is an argument that already exists in the context of this handling of the message right here. So we need to instead get what the coordinates of the point that we have just sampled. So this is going to be the X, and this is going to be the Y. Well, let's see how that looks, and of course I made a mistake. It's an L point, and an L point is a pointer to a point. Right? I think. Isn't? It totally is. So what is going on? I'm doing something wrong, probably stupid. Get cursor, and we're taking the address of this point. Is that correct? Of type oh, yes, obviously. We need a point. We don't need a pointer to a point here. Okay. Alright, so now we're still, everything still works, but look, I get outside of the screen, the window, and it still works. That is great. So now our mouse is no longer bound by the boundaries of our window, our mouse capture. However, take a look. If I go to the edge of the screen, and you can't see me, but I'm still pushing the mouse to the left, and it's not moving. So even that is not really good. Okay. Before we go and fix that, let's do something else. Let's say that it only moves when I am holding the middle mouse button. So we do like that, like a pan. Okay, so let's see how we do that before we go to fix that other thing. Okay. So we want to start capturing our mouse button states. So we're gonna add some more cases here for Windows message. What's it called? Let's see. So we have middle button and right button, and right, we have middle button up, and we're gonna have obviously a middle button down, right? we'll just do that for now, and we can deal with the others later. But for now we care only about the middle mouse button, and of course we don't have the constants for those, and I'm gonna just cheat and pull all of the mouse button constants, just so we have them. Okay, and we also have the double clicks of them, which we'll use shortly. Okay, Windows. So when we have a mouse button that goes down, we want to set some state that says that, so we can have mouse, and we may want to just have like a struct that represents our mouse, so we can have like mouse dot, actually let's do like set mouse button state. And we're gonna wanna pass, say, mouse buttons middle, right? We're gonna have a pointer to that. We haven't created those, we're gonna need to create them. And we want to say it's up, so it's gonna be false in terms of it being pressed. And we want to do the same thing for the same mouse button with true when it's down. Okay, let's start scaffolding our mouse. Say we have a mouse, and it's gonna be a struct, and it's gonna have some buttons, and that's also gonna be a struct, and it's gonna be a middle button, right? And let's say we have a mouse button struct, right? And it's gonna have an is pressed boolean, right? And maybe later it'll have other stuff, but for now I think that's enough. So we're gonna have yeah, that's a middle mouse button, right? And of course, alongside buttons we're gonna have a position, which is gonna be this guy, right? And a delta. And let's say we're just going to instantiate a mouse here. Okay. So now we don't need that, and it's going to be a mouse dot delta, and a mouse dot delta, and a mouse dot position, right? Okay. Of course, we also need to do it with these two. Okay, so we have mouse buttons, and we want to start having some set mouse button state procedure, right? And it's gonna take a button, which is gonna be a pointer to a mouse button, and the state, which is gonna be a bool. Oops. And for now, what we're just gonna do is gonna use this our mouse global. That's gonna do like oh, now actually no, we can use our button and say is pressed equals state, and we may want to do other things here, so this is why we did this procedure here, because we maybe want to capture where it was pressed, right? Yeah. So anyway, let's go back to here. Right, so of course I misspelled mouse. And we're setting the state of the mouse. Straightforward. Okay, so now in our application, in the update, we will only do any of that if, first of all, we need to fix our stuff here as well. Right. And clear the mouse deltas. And we want to do that only if the mouse button's middle is pressed. Right? We only want to have any of the movement happen while, as long as the mouse is pressed. Right? The moment we unpress it, when we release it, it's going to call this window message, and then we're going to update it to false here, and then in the update it will skip all that. Right? Okay, so let's just see what we can see. Syntax error in input. What did I do this time? Oh, I forgot to say struct. Probably cut that. Next thing I did wrong. Of course I misspelled position. Alright, so now nothing happens. As the moment I click the mouse button, now it starts moving. Now it's not exactly moving the way I like, but the moment I release, it stops moving. Right? So let's first of all fix this thing. I want to actually feel like I'm dragging it. So first of all, it's moving in the wrong way in both the X and Y. And it's moving too slowly. So let's fix both of those. So first of all, we want to have it move the other way, and we want it to also be modulated by some pan speed. Right? So I need to define our pan speed somewhere here. Yeah, just after speed, whatever. So our pan speed is gonna be, I don't know, 20. Oops. Whoa, that's a bit too fast. Let's try 10. Still too fast. Interesting. Let's do, I don't know, a third of that. Okay, that looks good enough. Let's see what happens if I click and then drag and then release it here. Oh, we have a problem. Now it doesn't work. It didn't catch me releasing the thing. Right? So, the reason that happened is, again, for the same reason that it was before, is that whenever our cursor is outside this window, this up thing, it doesn't get registered. It doesn't even get emitted for our window. So what can we do about that? So because these buttons, we are gonna use these messages for even when we do the raw input. So there is a thing that we can do. We can tell Windows to capture our mouse even when we go to some other window, like outside of our window. We still want to get messages when the mouse is captured. So we can temporarily capture it as long as the middle mouse button is pressed. And so let's see how we do that. So there is a call called set capture. So inside of here, when we when the mouse is pressed down, we're gonna capture our mouse and we're gonna pass in our window. And when the mouse is middle mouse button is released, we want to release the capture. So it's release capture, right? And of course we need to bind those, and I'm going to spare you, and these are the bindings for these guys. Pretty simple. Okay, let's see. So there's a window, I'm clicking and I'm moving and I'm releasing here, and it did catch the release, so now it stops moving. And then I can do this, and I can do that as many times as I want, right, in any direction. So now it all works regardless. However, we still have this same problem. If I keep pressing it, I'm moving, and nothing happens. So we're still bound by the edge of the actual screen in the monitor. So it's still not a good idea to use the position of the mouse based on the way we're doing it right now. So we still need to use the raw input, and that's gonna be the most complicated thing that we've encountered yet, because we're gonna go pretty low level in the Win32 rabbit hole. But the good news is it's gonna be the very last Win32 thing we ever do in this series, I think, at least for the foreseeable future. So it's gonna be a nightmare, but we'll just plow through that and we'll have our own raw mouse movement capture. Right. Actually, before we jump into the raw input, let's finish up a bunch of other things. So there's another small bitty thing that we can do. We can actually hide the cursor as we're moving, panning the screen there. So we can say show cursor here. We can say show cursor when the mouse is down with false, and we can reveal the cursor back when we've released the middle mouse button. Let's see how that looks. As you can see, it doesn't show even when it's outside this window, actually, right? Okay, so this is nice and working. This is a small thing, and while we're at it, let's just add all the other mouse button stuff. So we did the middle mouse button, but there's of course all the other mouse buttons. Let's see that. So we got in our constants, we did like left mouse down, left mouse up, and right mouse down and right mouse up, right? And they have the same thing, it's just an R and L instead of an M, so we can just go here and can just copy paste that. We won't be needing all the other stuff, but we do want to update the state of our buttons, right? So we don't need to capture or anything or release. Right, we just need to do this. So that's the middle mouse. Did all our stuff. And now we're gonna have like left button up, button down, and left mouse button up, and right mouse button down, and right mouse button up, and of course in here it's gonna be right for the right thing, and right here, and left, right and left here, and of course in our input thing we want to have more buttons, so right and left as well. Cool. Can actually put it like this. Alright. So currently this isn't doing anything at the moment, but just so we can see that it is working, in fact, we can say that if the left mouse button is pressed, we're gonna do print left. Right, and if the right button is pressed, we're gonna print right. Let's see. Nothing's happening. Right, left. I'm taking it up, and right again, and left. Okay, so this is working. Okay, so we finished capturing our mouse. What we could do is also capture where the mouse was clicked and when it was released. Maybe we can do that later, now that we already know how to do that, using these calls here. If we put it here and we pass it and we implement some stuff there, then we can do that, and maybe we'll do that later. One more thing that we could do is also use our mouse double click, because if you remember way back in the first episode, I think the first session that we did this guy which says, hey, support double click, and we haven't used that, so let's also use that because we can. Let's say we only care about the left mouse double click for now. So we'll go to Window, and let's implement this case. So when the left mouse button is double clicked, we could actually do the same behavior that we had earlier, which is that while we can do like a modal thing where like we double click once and we enter one mode in which it's continuously captured and we don't have to hold the middle mouse button, and then we can double click again and disable that mode and get back up again. So we basically want to do what holding and releasing the middle mouse button would do, just in kind of a more modal way. And we'll use it way later in the series. So we have two behaviors, one like this, one like that. Right? So we want to enter the capture mode if we're currently not captured, right? So we need to just store the state that we're currently at, the mode that we're currently at, somewhere. So we can just have like a mouse is captured, right? And we can say, well, if the mouse is already captured, then we want to uncapture it, like release, and reveal the cursor. Right? And we want to say, well, mouse capture is now going to be false. Otherwise, we'll do the opposite. Right? Whoops. Yeah. Alright. And if it's not already captured, we want to capture it. Right. So now, of course, we need to add that field to our mouse in the input. Cool. And what we can do then is say in here, if either the middle button is pressed or the mouse is captured, then we do all that. Let's see how that looks. So we still have the same behavior as before. Now I'm double clicking. Look at that. Now I'm not even needing to hold anything. Still have the problem of hitting the edge of the screen, which we'll get to in a bit. And then I double click again and I'm out of it, and the other behavior with the middle mouse button still works. Alright. One very last thing before we go to raw input is, while we're at it, just finishing up, we'll do also a mouse wheel, because why not? Yeah. Okay, so we'll put here a case of, I think I already have it. Yeah, mouse wheel. Window. And if the mouse wheel was moved, we want to tell our mouse that it was moved. So we can say mouse wheel scroll, yeah, whatever. And we want to set it, actually, let's just say on set mouse wheel. And we're gonna pass some scrolled amount. Let's see how we implement that. So again, we need to use some crazy wacko macros from Win32. that's gonna extract the mouse wheel amount from the parameters that we have, the arguments that we have in here. So it's gonna use the W param, and it's gonna have this wacky macro that extracts the value out of it. Let's see what that does. We'll go to our bindings and we'll just paste this guy. Just do that and inline it. Okay. It gets a W prime, it turns it short, and it does a bunch of conversions. And as you can see, it's also using the high word that we already have here. So good for that. Okay, so it's going to return a short, which we know is an I16. And that's going to be the wheel. Now it turns out that there's also like a constant that's specific to window, which will be like how much is a one delta of wheel scroll or whatever, and in terms of like how Windows think of it. And we can use that to kind of normalize what the wheel scrolling values that we get in kind of like a cross-platform way. So we're gonna have some constant here. It's gonna be this guy. It's just 120. That's the wheel delta. Again, it's just a constant in the Win32. You can get it in the same way that I've shown a million times how to get stuff. And so what we want to do is basically divide by that thing, but we don't want, because like we're dealing with integers and it's going to be a very small value, what we actually want is say convert this into an F32 first, then divide that by this, which we also need to cast to F32. Yeah, so the set mouse wheel is going to get some F32, some fraction. Okay, and we of course don't have that yet, so let's implement it. So we're going to input, and for our mouse we're going to set the mouse wheel. It's going to be a proc, and it's going to get some amount that's going to be like F32, right? Okay, so we're gonna have to add a wheel to our mouse. Yeah. So wheel, and yeah, well, we can have like a struct that has an scrolled boolean and scroll amount, which is gonna be, I don't know, can say it's like an I16, like it's gonna be, yeah, we'll just convert it back to an I16 and we'll modulate it to be some value. So we're gonna have some fraction which is gonna be representing like the fraction of a full scroll wheel. So we can say, well, our mouse wheel scroll amount just increment by the amount that we get. However, we're gonna want to multiply a fraction by 100, so it's no longer like a percentage, it's an actual number, and we want to like an I16 that, because we want an I16 for that amount. There we go. And we're going to say, okay, the mouse has obviously been scrolled, and so we can check that. then we can check that in our application layer in the update, say. So just so we can see, like, if the mouse wheel scrolled, then we're gonna print mouse wheel scroll amount. And we're gonna say mouse wheel scrolled is now equals to false. We've handled that scroll event. We're accumulating that, so we're expecting to see it go up, yeah, and then go down, and go to minus even, and we have a scroll wheel. Great. All right. We are almost there. Let's do the raw mouse input capturing. So the first thing that we're gonna have to do is register the fact that we're capturing mouse events, raw input, sorry. So we're gonna need a raw input device. And we're gonna have to register it. So we're gonna have this, I did it before. Okay, so we need to register a raw input device, and this procedure it looks like that. In the bindings, so it expects a PC raw input device. Okay, so what is that? Uint we already have, bool, it's fine. What's this? Well, it turns out it is a pointer to some struct. So let's see. Of course I'm cheating, I'm sparing you the trouble of going through all of that. Yeah. Okay, let's keep our long pointer to a message. So this thing is just a pointer, right, to this struct. Is a ushort, dword, and some, the window handle. Okay, so we need one of these. So that's instantiate one. We're just gonna reuse it all the time. So it's gonna be like this guy, and it's gonna be our raw input device, right? So we'll call it that. That's our raw input device. Now we do need to set some flags on it to tell Windows that we are actually interested in capturing mouse events. So I'll spare you the trouble of seeing how we set that up. Is just using some constants to say what we're using. Okay, so, and this is going to return like an error. Maybe I don't know, maybe we don't have a mouse connected, so we'll get the error. And by the way, we need to obviously pass a pointer to this thing and a bunch of other stuff. But say like when, we'll just copy this thing, right? When if our, we can say just, if we got any error, then we're gonna say fail to register raw input device. Alrighty. So what are all the other stuff in this register thing? You know what? Okay, let's do that. We can go to MSDN. Register raw input device. Let's see. How many devices and some size, which is the size of the raw input device itself. Okay, that's pretty boring. Alright. So we have one device that we are interested in, and we get the size of and of course I'm doing it in the wrong place. Okay, so one device and size of our raw input device. Alright, so we have done the registration. Well, let's see what else we need to do. What we actually need to call to get the raw input, first of all, we need a message that we need to capture, and not surprisingly is gonna be case Windows message input. Right, and the actual the actual call that we need to do to window is this: get raw input data, and it is a doozy. So let's see. Get raw input data function. First of all, let's get the bindings for it. We'll see. Okay, so we're passing a handle, right, to the raw input. Is that correct? First one, handle to a raw input. Okay, and then we need to pass something here. Command flags. This primary one of the following: get the header information or get the raw data. Okay, so and this is a pointer to the data that comes from the raw input structure. So we're gonna, first of all, we need a raw input structure, whatever that is. So it's kind of a rabbit hole. It goes a bit deep, and by the end of it, I'm just gonna save you the trouble. First of all, this is get raw input data, right? And we need a handle to a raw input, and this is just gonna be another one of those handles. So we'll go to type, and we go this, and we go that, and here we have a handle, and we need yeah, we already have LP void. Yeah, we already have point. No, it's pointer to a uint. It's not point. Okay, so what's a pointer to a uint? Well, it's obviously uint. It's a to a uint. Duh. Okay. And uint we already have. Great. So that's get raw input data. Let's go back here. I want to what's this? Well, the LP void is just the raw pointer, but it actually has to be this struct. Okay, so we need a raw input struct, this guy. Okay, so raw input struct, let's see, is going to be looking like this. In our structs, we'll add a bunch of stuff. That's a raw input device, and that's our raw input, and that's like a handle to a raw input. Yeah, anyway, we'll get to that. So we have here raw mouse, raw keyboard, and raw ID. Okay, so raw mouse, right? That's the thing that we actually interested in. So raw mouse is going to be this. U long, we have U long, U short, blah blah blah, all kinds of union stuff. We're gonna need this last X and last Y. And we can tell Windows that we're actually interested in getting deltas in those, right? Do raw buttons, but we're not going to do that. Okay, so that's raw mouse. We need raw keyboard. Well, raw keyboard is gonna, even though we're not going to use it, we still need to define it in the bindings so that the bindings will work. So this is raw input, raw keyboard. It has some U shorts and U ins and U long, and that's fine. Okay, and we have a raw ID. And the raw ID, oops, is gonna look something like this. Just a byte and a D word, blah. Okay. So we need to pass a pointer to this raw input thing. So it's not a raw input device, it's actually the raw input itself, where the data is going to go for that raw input. Okay, so we need to instantiate some stuff here. So we need the raw input. Well, we'll just call it raw inputs. It's going to be a raw input. Yeah. And we're going to need a raw input handle, which is, we saw it's just a handle to a raw input. It's going to be like the identifier of our raw input. And we are going to need this size of raw input. So it's just going to be an int raw input size uint. I'm just, yeah, raw input size pointer, because we're going to need a pointer to that raw size that we're going to need to pass in. Pointer. It's going to be this puint thing that we saw. And it's just going to be like a pointer to our raw input size. However, we need to cast this thing to our this thing, because it can't be just a regular pointer. It has to be this kind of pointer. Why? I don't know. But it has to be that. And the last thing that we're gonna have to pass in is a raw input header size, which is also gonna be a uint. It's gonna be a uint. And it's just gonna be whatever the size of raw input header, which we haven't talked yet about, I think. Yeah. Where are we? Yeah, because we need to, yeah. So it's this guy. So the header is gonna have a type and a size, and we need to pass the handle and a W param. Okay, the W param is what we're gonna get from our messages. And we're gonna have like a raw input comes from some device that is not a keyboard or a mouse. Okay, type keyboard and type mouse, and type mouse is going to be 0, and we are interested in type mouse, right? So we're gonna have to use that, and we're gonna just set it to a 0. Okay. So in our constants, we're going to set this thing to be 0. We're going to be using that in our application. Not in our application, sorry, in our window. In our input thing that we're going to use, I'm going to need this guy somewhere. And we need the header struct. Raw input header struct is going to look like this. Raw input, that's fine. We have a raw input header, like that. And we need something called a handle, and it's just a regular handle. So let's go to our constants. Is that constants? No, types. And just create a handle thingy. Okay. Alright, let's see that we have all our bindings in order. We'll go to window, and we'll comment this out for now. Let's just see. Ulong, we don't know what a Ulong is, really. It's just an unsigned long. Okay, types, long. Okay, that's a long. The Ulong is this. Okay. Next. Raw input size. Undeclared name. Raw input size. Raw input device. Raw input device. Did I mistype it? Raw input device. No. Oh. Okay. All right. registered our raw input device, and we have what we need, and the bindings is working, presumably. So the thing that the way this is going to work, and this is really weird, and I'm not gonna want to get too much into it, but basically we have to call this twice. If we go to Window, the documentation, I think there's like an example here that shows how to do that. So you can give it a buffer, or you can give it just one thing. Basically, the first call is just gonna get the size, and if there's a size, then we call it again to get the actual data. That's kind of the way it goes with this. So let's see how we do that. So the first thing is get raw input data. We need the age raw input. This is our raw input handle, which we have made raw input handle. Right? Where's our input? Here. That's the first thing. Second thing is bindings is gonna be the UI command. Okay. Get raw input data command. Okay, so we can do like header, or we can do input, and they have two different things. Let's see. So we basically always want to use the input. It's going to be this. So RD input. I think I already got it before in here. Did I? No, it wasn't that. So we need this RD input, and we don't have it, of course, so we can just grab this and go to here to constants, and we're gonna do this. Okay, so Windows. So we have our raw input. It's back to bindings. So we have our UI command. Now we have to give it the data, and the data is going to be our raw input thing, but we're gonna have to cast it to this LV pointer thing. So it's gonna be our pointer to our raw input data, but we're gonna have to cast this to an LV pointer thing, and this is like the pointer to where the size is going to be put in, that we're getting from this raw input get raw input data call. And so we have this size, and we have this size pointer that we already set up for ourselves to put this into this size thing, pointing to that size thing, and our input, yeah, so it's gonna be that. Bindings, and the last thing is the header, and it's uint. Oh, the size. right? Yeah, okay. And I think we already have that. Header size. Okay, that's the last bit. Okay. Whew. So we had this and this and this and this. So we get that, and this returns to us a uint, which get raw input data, returns a uint, return value, if it's null and the function is successful, the return value is 0. Oh, if we didn't pass any data. If pdata is not null and the function is successful, the return value is the number of bytes copied into pdata. If there's an error, it's going to be there. Okay. So, yeah. So the first time we're calling it, we're just really gonna be asking it if there's some data awaiting for us to be picked up. So the way we do that is we just pass a nil here instead of the actual data. Let's capture the result. And because we have passed a pointer to the size, then this call, which should be 0 in this case because we don't want any errors. If result is equal to 0, right? And it turns out that we do have some data waiting for us, which is going to be this raw input. No, sorry. Our raw input size, but not the pointer, the actual size that the pointer points to. If this call ended up populating some value, non-zero value, into this size, then we're gonna end up calling this thing again. Like that, and this time we do pass pointer to our raw data because we actually want to get the actual data, right? And again, we want to get the result, and again we want to ask whether the result is 0, so we don't have any errors. Actually, no. So because when we, as it said, like when we pass here, the result that we're actually gonna get in this case is gonna actually be how many bytes were filled into our data here. So if it turns out that the result is equal to the size that we're expecting it to equal to, right? So it has filled the amount that we're expecting into our raw data, now we can start querying what's inside the data that was populated. So this guy has a header, as we saw in the struct. That header has a DW type, which means what kind of raw data are we looking at here. And if that thing is this thing, which signifies that it is indeed a raw mouse input data, then then we can start querying the data that we got back. One last thing that we forgot to do before any of that, so we have this raw input handle, and we need to populate it with basically from our L param thing. And of course we can't just populate it like this. We need to basically transmute it to this particular handle. So it's going to be transmute to a handle to raw input, and we need to convert this thing first to an int, and we can't just transmute it into like a raw pointer directly because Odin doesn't like that. So we need to first convert it to a uint footer. And so if I've done it all correctly, then we'll get the raw input handle that for our current session, from the gram of our message. And then we can use it in all these two calls, and eventually we go up to here, and then we can start querying the data that we actually got inside of the raw input data in the buffer, and that's gonna be the data, our raw inputs, and it has a data member, and that data member has a mouse. Again, we can go here. We have raw input, it has data and has a mouse, and that's a raw input, a raw mouse. This raw mouse has a last X and last Y. These are the stuff that we want. L, right? Yeah, and there are longs, and long is an I32, which is exactly what we want. Okay, so we have these. Actually, we can just do like using raw input data mouse. And then finally we can make the call to mouse moved, right? So, and instead of mouse moved with the point, we'll just say mouse moved with our last X and last Y, and the default mode is for it to return deltas already. So in here we actually can just populate the data itself directly. All right, and then we actually want to be needing this stuff, or this point We're no longer querying it directly ourselves. Instead, we're trying to get the raw input data coming through here. And what are the chances that I haven't made any mistakes? Virtually nil. Undeclared name raw input data. Really? I have not instantiated the raw input data at all. Have I? Yeah, because it's actually our raw inputs dot data, I think. Yes. Alright. So it's our raw inputs. Where is it? Oh, first of all, we haven't said this thing. It's another event, and it's like a message. It's gonna be raw input in constants, like that. And in window, raw input dot data, right, and raw input dot data header. Yeah, no, undeclared name raw inputs, raw inputs dot data, raw in. Is it? Wait a minute. Oh, yeah, it's not data, it's just the header itself. Oh, we need the wrong input, not the input data. Passing the wrong pointer there. Let's try it again. There we go. Alrighty. So that was it. And so if we're having anything to report, then we report. Okay, and we don't need this thing again. Messed something up. Don't need this. Okay, we're moving, and there we go. And look at that, it's all working, and double click also works. And when I move, look, I'm going to double click, and you can see my cursor, and I'm moving onto the edge of the screen, and then I keep moving, and look, it keeps going and going and going and going and going forever. Because we're getting our deltas all the time, no matter what. This is what we're after. There we go. Okay, this is it for this session. I hope you enjoyed it. Yeah, apologies for the trouble with the mouse input stuff. It's always challenging, but we've made it. So we've basically are done with our entire platform layer. Starting the next session, we'll be focusing on rendering and the good stuff entirely. So I hope to see you there. I hope you'll come and check the next one out. I know this one was long, but I really wanted to get everything out of the way so we can focus on the fun stuff from the next session on. Thank you very much. If you like it, you can click the like button, and if you want to subscribe, as always, you can click the subscribe, and then you'll be notified for when I upload the next session. Thank you. Bye bye.